to be able to present our company at the 16th Colloquium 2017 in Bled. My name is Christian Wodratska, and I am the Managing Director of S&P Austria and also responsible for the market in the ex-Yugoslavian territory. Our office in Vienna and warehouse is close to Dreiskirchen. That means approximately 15 minutes in the south direction to Vienna. Actually, S&P was founded in Switzerland 1995. S&P stands for sharer and partner. And since 2012, it is part of Simpson Strong Die Company, headquartered in Pleasanton, California. Nice weather, by the way. The company is a leading manufacturer of wood construction products, including connectors, fastening systems, shear walls, and as well as concrete construction products, like chemical anchors, like concrete screws, and other things more. In Europe, we have 3 main production lines for S&P. The first is in Iberica, in Portugal. That means here are the production of the laminates. It calls FRP or carbon stripes. FRP, CFK laminates, to strengthen bridges, to strengthen substrate, what else? And the other thing is in Portugal, close to Lisbon. The third thing is the facility in Poland. The facility is the second one. That is the production of our really asphalt grid. Asphalt grid. And the third line is the armor line in Spain. All the mortars coming to there, close to Madrid. This next slide shows a little bit a peek inside. This is Poland. Poland with the silo tanks, not the silo tanks, the bitumen tanks, of course, the weaving machine, and of course the facility. Other thing on the other side is Portugal, the production of the laminates, CFK laminates, and you see on the right picture there are a lot of carbon rovings. You can see it on my booth, on our booth. There is a carbon roving actually there. Then is the production of the laminates. Okay, let's go a little bit deeper. The next slide, why? The next slide shows not only, I guess, a great picture, I guess on slide 5. The question is more, why do we need such an asphalt grid? Well, every one of you knows how bad streets can look like, potholes and cracking in every imaginable sizes and form. Most of them fighting with problems, like overstepping the bearing capacity of the asphalt, completely asphalt construction, some difficulties with exceeding the maximum elongation, and many more reasons to bring the asphalt to the end of its functionality. Today I'm talking about, of course, our S&P asphalt reinforcement grids made completely of glass and or carbon. That's the difference, glass and or carbon, which have an excellent shear bond behavior, prevents crack reflections, crack formations, and if they applied on the right level, they also could help to slow down the rotting process. Mostly applied between wearing and binder cores. The higher, the better. You can compare this functionality of our grids like the steel reinforcement in concrete. Our products really are not a traditionally fleece or a combination with other materials, so-called combi product. We are going deeper, we are going to strengthening something. That is why we use glass or carbon. On the next slide you see why we have chosen this material, the glass. Because we have a low elongation but a high tensile strength. So approximately 1.6% for carbon and 3% for glass. You see the other materials, so approximately 15% elongation and 10% polyester, polypropylene. That's the different kind what we are talking about. The advantage of this fiber is also the opportunity to mill and recyclability without problems, because the glass and carbon fibers are really a brittle fiber. And in the machinery, when you mill it, so around 7 centimeters at maximum, you will get out. And there is no problems for the recycling. So these characteristics we can achieve, of course, with that higher stiffness of the whole construction, or a designed part, of course. Further, a strain reduction of the asphalt because the loads are dispensed and anchored into the mesh. And as I mentioned earlier, we are able to reduce the cracking and rutting process. The result, after all, is that reinforced streets can definitely carry more loads due to the possibility of increased tensile strain, and this leads us to longer maintenance intervals. That's what we hear, which is the most important for the road owners, not for maybe the asphalt companies. So, what can I say? How can we this achieve? From my understanding, the most important value is the shear bond. If the shear bond is missing or very low, like on my special picture for you, it's called skremšnita in the Slovenian language. Hopefully I pronounce it right. The streets must maintain sooner as planned. For me, as an engineer, it's like a snack between, but not to achieve high absorbing stresses. This could happen when you choose the wrong or not adequate material, what you can find, missing shear bond, missing flexibility or something else. This could happen when you apply the wrong material on the right level. To prove this shear bond behavior, we made a bunch of tests across Europe. And one of them was carried out, of course, in Austria at the Technical University of Vienna. The specimen was there, 100 millimeter core, according to Marshall. And in other countries, we use 150 millimeters. In Austria, we have to reach 1.2 Newton per square millimeter as a minimum number of the national guideline, RVS. In other countries, in our test, we did it in 2016. The unreinforced specimen shows a number of 1.7 Newton per square millimeter. And with our grid, we reach a really high level because we achieved 1.5 Newton per square millimeter for a 100 millimeter core, please. This was really close to the zero sample, all done hot on cold. The blue one, the 3-point, is hot on hot. Of course, we did some tests in Germany as well, the Leutner test with the 150 millimeter core, and you see the same results. We achieved, according to them, to the zero sample, 29 kilonewtons. That means approximately 88%. The specification in some areas is around 15 kilonewtons, so that means we achieved them very easily. On the next slide now, you can see I have guided some pictures, and you can see how we can do this. This is, I called always, this is on the left side is the big mummy. It calls the big asphalt machine, because the weight of that is so around 900 kilograms. You have to use a forklift, similar machines, or a pallet handler, of course. A pallet handler, you have to push this asphalt grid. And one roll, the weight of one roll is approximately 60 kilograms for one roll. That means we have a lot of bitumen on it, not a coat, not elsewhere. It's really a bitumen. Or you can take the small application device, the manually device around 90 kilo, and you can burn it to death, this grid. Then you have a perfect bonding system. The tech code we used is always PMB, bitumen, polymer bitumen. The amount of this, it depends a little bit, is only, now you can see the advantage, the only 0.3 up to 0.5 kilogram per square meter. Because of what? Because of our pre-bitumination. That's why we achieve so much high shear bond value. And the other reference is, of course, there is not only streets, we can also do bus stations, airport. We have done great experience with airports. In Göteborg, we are close to do every airport now, with 2 or 3 layers. And for that, I would like to say thank you very much for your attention.